Okay, first one I want to look at. Let's see, we've got a pyramid is given to us with a volume of 2,706 cubic units. So they give us the volume, they want us to, and they give us X, right? And they want us to find the height Y of the pyramid. So what do we do for problems like this, where we're given a formula or a volume or a surface area, and we're asked to find a missing dimension? We always do kind of the same stuff with these. What do we do? Write down the formula. Good. Start with the formula. Okay, so the volume for a pyramid is really simple. What is that? Okay, base times height times 1/3. Good. Base times height. Now, what is the shape of the base here? Square. Sure. So the base area, B, capital B, is really easy to find. What is that? X times X. So 15 times 15, that's 225. We got it, right? We're given volume. So all we have to do then, we can plug in the stuff that we know, and we get 2706 equals 1/3 times 225 times H, and we're solving for H. So what do we do? Yeah. Okay. Okay. There's a couple things we could do. We could divide 2706 by the whole quantity, 1/3 times 225. That's fine. Or if I want to, I could take it in 2 steps. Now remember that the game we play with this, when we're trying, and we can do this on our calculators, when we're trying to do the algebra to isolate a variable, we're pushing everything over to the other side of the equation, right? So the number that we end up with on that side is H, okay? So we're starting off with the 2706. What's the first thing we would do maybe to get the... Okay, multiply by the reciprocal, multiply both sides by 3. Okay, to get rid of the 1/3. That's a good idea. So we'll take this and we'll multiply by 3, and that gets rid of the 1/3. Okay. Okay, divide then that answer by 225. And we got it. 36.08 is H. Okay? No big deal. Make sense? Okay. I think what you're going to find, honestly, even though the assignments for the pyramids and prisms were definitely harder, after having gone through this now a couple times with the class, I honestly think this test is easier than the other one. Once you get through, there's just a couple little hurdles, and they're not big. I think what you find is that the problems on this test, there aren't any of the really hard ones. I really believe this is an easier test than the other one. Okay, so moving on. Okay, next one. Find the surface area of the regular pyramid, in this case, right? So this is, now when we're just finding a surface area or a volume, we're just going to plug into the formula. Plug this stuff into the formula. So what, our formula, you already, no you didn't. What's the surface area of a pyramid? How many bases? 1. Okay, so base, 1 base plus yeah, good. 1/2 PL. So there's the base plus the lateral area. Now this is a pretty easy one because they give us slant height, right? The only thing we've got to do that's remotely difficult here, and it's not bad at all, is find the area of the base. Now what is the shape of the base this time? Okay, and what kind of triangle? Equilateral. Good, because here's the base, right, in red. There's one edge. Here's the edge that's dashed because it's behind the pyramid. And there's the other one, right? Notice that they're all length X, so it's equilateral, right? So finding the base is not a big deal. We're just going to follow the formula. Does anybody remember what the formula is for the area of an equilateral triangle? Square root of 3/4 times side length squared. In this case, x squared, and x is given to us as 12. So that's it, right? There's the base area. Base perimeters are always very easy to find, right? If it's a regular shape like this, where it's all the sides are the same, what do?
Times 3.
Yeah, just multiply the side length times the number of sides. So the perimeter would just be 3 times the side length 12 is 36. And what about the slant height?
30.
It's given to us. The slant height is the distance up the middle of one of the faces, and that's given to us as being 30. So let's plug it in. That's it, right? So grab a calculator. Let's calculate the base area, how about? So square root of 3, get out of the radical, divide by 4 times 12 squared. There it is. There's the number for the base, right? So all we've got to do then is add that number to 1/2 PL. So plus 0.5 times 36 is our perimeter, we said, times the slant height we said was 30, right? That was Y. And that's it. 602.35. That's our surface area. Okay? No biggie. Alright, so what's next here? Okay, what kind of a shape is this we're working with? Okay, a triangular prism. What kind of triangles? Equilateral. Good, because we can see that the congruence marks tell us all the sides are same length, right? All going to be x. And so, same as the first example we had, we're given a surface area this time, and we're supposed to solve for A. Now, what is A? The height. Good. The height of the prism, distance between the bases. So, what's our formula for surface area of a prism? Okay, that'd be volume. We're doing surface area. Okay, 2 bases this time. Good. Plus pH, sure. And H is what we're trying to find, isn't it? Okay. So base, just like before, it's an equilateral triangle, so that's no big deal at all. Square root of 3/4 times x is 3 this time, so 3 squared is our base. What's going to be the perimeter of the base? 3 times 3. So 9. And we're given surface area, right? So all we've got to do then, if we write this equation out, we've got, we've got 844 is our surface area equals 2 times b, and we have a number for b, don't we? Plus p is 9 times h. Okay, now remember here though, when we're trying to solve for a variable or isolate a variable, we're pushing everything over to the other side, right? We have to remember to follow our order of operations in reverse. So we reverse PEMDAS. What's the first step we take then? Good, subtract. Okay, good. So let's how about if we calculate the base? We get a number for it. Square root of 3 divided by 4 times 3 squared. That's our base, so pretty small. There's b. So now let's do the math. We've got 844 already over here. We're just going to keep a running tally of what the number on the left side is. So first you told me I subtract, right? Okay, I subtract 2 times our base, which we just calculated, so we'll grab that. Okay, there's what we get so far. And we've gotten rid of those guys. Okay, now what? Divide by 9. That's it, right? Divide by 9. So divided by 9. Get rid of that. And I got the h by itself, and there it is, 92.91. Yes, ma'am?
Since it's like 2 times that by 2, or is that already like in the base?
We did multiply by 2. See, I had 844 minus 2 times, and then I just grabbed the base number. Okay, so you're right. You do need to multiply by 2. Okay? Other questions? All right. Yes?
Is the height is A, right?
Yes.
And the height is the distance between the two bases?
Yep. Yep. So I probably should have called it A. I just called it H in here. But that's what we solved for, was A, the height. Okay? All right. Very good. Okay, this one, this one isn't really a big deal. I know why people miss this one. Looking at the answers, too, it's pretty obvious. People miss this one because they didn't add one of the surfaces. Now, let's read this question here. The center of the sphere is at C, and its circumference is 5 pi. So what does that do for us if we know the circumference, first of all? Say it again. We can find the radius. We need the radius, right, in order to find the surfaces, the areas of the surfaces. Okay, so the sphere is cut in half as shown, and the two hemispheres are separated. What is the surface area of one of the hemispheres? So what people tended to do with this, if they missed this one, they calculated the area of the rounded part of the hemisphere, which is what? How would I do that? Okay, find the area of the whole sphere, just cut it in half, divide it by 2. And that was their answer. What did they forget to attach to that surface area, though? Yeah, that circular base that we created when we cut it in half, right? So that's where people tended to miss this one. All right, so first of all, let's find what r is. If I know the circumference is 5 pi, and that's equal to 2 pi r, what do I do to solve for r? Okay, divide both sides by 2 pi, good. So the 2 pi cancels, and I just get my r on one side. On the other side, the pi's cancel. And what is 5 over 2? 2.5. Okay, good. So I know the radius is 2.5. And then if I want to find the area of the hemisphere part, the rounded part, that's just half of a sphere. So we'll just do 0.5 times 4 pi r squared, and r is 2.5, right? So there's half of the area of a sphere plus, what's the area of that circular base? Pi r squared. Yeah, that's the area of a circle. So pi times 2.5 squared. Okay, so all I've got to do is just do that in my calculator. So 0.5 times 4 times pi times 2.5 squared plus pi times 2.5 squared. And there it is, 58.90. Okay? We good with that? Okay, so far so good. Okay, this is probably the hardest one on the test, and it's not that bad. Find the surface area of a pyramid. Probably the hardest kind of surface area to find would be a pyramid. So we already said that the surface area, the formula for the surface area of a pyramid, already told me, is it's 1 base plus 1/2 PL. And the hard part of this is just the slant height, like always. Everything else is not too bad. What's the shape of the base? Hexagon. Yeah, it's just a regular hexagon, isn't it? So the base area we can calculate. Do you ever remember the formula for the area of a regular hexagon? Okay, I could do square root of 3 over 4 x squared times 6 for the 6. There's actually also a formula on the sheet. Yeah, 3 root 3 over 2 times x squared, and x is 4. So that's our base area right there, right? While we're at it, the base perimeter would just be what? How many sides? Each one is length 4, so 6 times 4 is 24, no big deal. Okay, what about that slant height though? The slant height is the distance up the middle of one of the faces, right? So what we're looking for here is the slant height right there. That's L. Now what they're giving us is an edge length, not a slant height. So when they give us Y, they're actually giving us that distance, and they're telling us it's 11. So would you agree that if I take one of these faces off, the slant height goes right down the middle of the face, so it must form a right angle with the base edge, right? What's going to be the length then of this little piece down there? Okay, good. It's half of X, isn't it? Because it's cutting that face in half. So if X is 4, that distance is 2. So let's look at that triangle a little more closely. Pull that one off and make it a little bigger. So there's the slant height. There's the edge length, 11. And here's the other leg of that right triangle, which we said was 2. So what does the Pythagorean theorem tell us about those 3 sides then? Okay, so say it again. What squared plus what squared equals what squared? Okay, so 11 squared plus 2 squared equals 11 squared. 11 is the hypotenuse, so that's got to be by itself, right? So we get L squared equals 11 squared, whoops, minus, not plus. Well, here, let's not even do that. Let's start with the, I'm just going to start with the Pythagorean theorem. So L squared plus 2 squared equals 11 squared, right? So if I subtract 2 squared from both sides, that's going to give me my L squared. Everybody agrees with that? L squared is 11 squared minus 2 squared. Okay? And then to get L, I'll just square root both sides. Okay? So there's L. So that's all. We've got all the parts we need of that equation then, right? We can just calculate those numbers and put them in the surface area equation. So let's calculate, how about L? So L was the square root of 11, oops, not 111, 11 squared minus 2 squared. So there's the number for slant height. The base area of B, let's calculate that. That was 3 times square root of 3 divided by 2 times 4 squared. Okay, there's the base area, and the perimeter was 24. So we can put all that stuff in here then. Base area plus 0.5 times 24 was the perimeter, times L was right there, 10.8 something. Okay, now let's hit enter, and we get it, 171.37. Okay, that really is probably the hardest question on there. That's not that bad. Okay, this one. The radius of planet X is 6,397 miles. The radius of planet Y, quite a bit smaller, 1,063 miles. How many times more surface area is there to map on planet X than on planet Y? Now, where people had trouble with this was not calculating the surface areas. That's pretty easy. The question was, how do you do this? How many times more business? How many times more surface area is there on the big planet than the small planet? Now, think of it this way. What if we wanted to know how many times higher is Mount Everest than Mount Hood? Mount Everest is about 29,000 and I don't know, some change. So it's slightly over 29,000 feet. Mount Hood is 11,235, I think. Maybe it's 235. So we'll just say 11,200, how about? If I want to find how many times higher Mount Everest is than Mount Hood, what would I do on my calculator? Divide, sure. I would just divide 29,000 by, we'll just say 11,200. And we get roughly 2.6 times higher. So we'd have to take a little over 2.5 Mount Hoods stacked up vertically to equal Mount Everest. Okay? So for us then, we're not doing Mount Everest and Mount Hood, we're doing planet X and planet Y. So all I need to do then, what's my formula for surface area of a sphere? Okay, so surface area is 4 pi r squared. We have the radius of each planet, so we can just calculate each number and divide, right? So I get 4 times pi times 6397 squared gives us a huge number, about over 514 million square miles. That's big. It's quite a bit bigger than Earth. Second one, so we get 4 times pi times 1063 squared, 142 million roughly. So we'll just divide the first big number by that second smaller number. And we get about 36.21. So over 36 times more area on the big planet than the small planet. Okay? Make sense? Does that seem reasonable?
Yeah.
It's a lot. How is it that that's the case when the big planet is just a little over 6 times bigger than in radius than the small planet? How come the surface area is so much bigger? Because you're squaring it. Exactly. Because you're squaring it. That makes that difference much bigger. Okay, what about this one? This looks pretty complicated, but it's not. It's not a big deal. What kind of a shape is this? Good. Hexagonal prism. Good. It's a regular hexagonal prism. So we're given the volume of this thing, and this is volume. Good, right? Volume, we love to see volume. Those questions are always going to be easier than the surface area questions. So they give us the volume, they give us y, and we're supposed to find x. Now, what is x? Height of the prism. Good. Okay. So we've got our formula for the surface area of a prism. I'm sorry, volume of prism. Is really easy. What's the formula for volume of prism? Base times height. That's it. And we're looking for the height. So what do we have to do then to solve for h? Good. Find the base area, and then divide volume by b after we calculate. That's it. Okay, you already told me that the area of a regular hexagon is 3 root 3 over 2 times the side length, in this case 12, squared, right? They give us volume, so all we've got to do then in our equation, if we know that V equals BH, I can just do all that on my calculator. So let's calculate B, how about? 3 times square root of 3 divided by 2 times 12 squared. There's the number for base. And then now I'm just going to divide the volume, which is 3494, divided by that number. So 9.34 is the height. Okay. Questions? Right. We're getting there. Okay, this one. Okay, this one's a little. It looks like a crayon. Yeah, this one's a little harder. We've got, but it's not bad. I mean, I really don't think it's that bad. I forgot one thing on this picture. They give us the radius, or they give us the diameter. Actually, they tell us that x is that dimension, and they give us x. So then we need to find the total volume of these two shapes. What are the two shapes? Cylinder and a cone. And fortunately, we're dealing with volume, so what do we do when we find those volumes? Just add them up. That's it. Find the two volumes and add them up. Then there's one little wrinkle at the end we have to take into account, but we won't worry about that yet. First, let's just find the overall volume. So we know that the volume formula for a cylinder is what? Yeah, good. It's just the base times the height, but the base is a circle, so it's just pi r squared h. Now they give us the height, y, that's 42, right? But what about the radius? Okay, they give us the diameter, so we've got to divide that by 2. So the radius then is 11.43, so that's going to be 5.5715. Well, just 5.715, sorry, 5.715 is the radius. So we can plug that in, and that's an easy thing to calculate then, isn't it? We can just plug those numbers in. Pi times 5.715 squared times the height is 42. Agreed? Calculator work, no big deal. Okay, what about a cone? What's the volume of a cone? Yeah, it's just the same formula, but times 1/3. So 1/3 pi r squared times the height of the cone this time, different height, right? So the same radius though. Do they give us the height? No, they don't, do they? What do they give us? Slant height. Yeah, they give us the slant height here, which is 13. But we can, how do we get the height from the slant height always? Pythagorean theorem. We make a right triangle. Good. So we've got the radius, which we know, and we're looking for the height. There's the height. The radius we have, that's 5.715. So what does the Pythagorean theorem tell us about h and these other numbers? Okay, I heard it. So h squared plus 5.715 squared equals the hypotenuse 13 squared, right? So to solve for h, wouldn't I just subtract 5.715 squared from both sides? So h squared equals 13 squared minus 5.715 squared. What do I do to solve for h? Last step? Square root. Okay, so there's h. We need h in our formula, but now it's just calculator stuff, right? So let's do this. Let's calculate. How about if we calculate height first? So the height is of the cone. The square root of 13 squared minus 5.715 squared. There's the number, right? That's the height of the cone. So let's go ahead and get the volume of the cone then while we're at it. So we need 1/3 times pi times r 5.715 squared times that, times h. But we already calculated that. It's right there. We'll just go grab it. And there's the number for the volume of the cone. Okay, to get the volume of the cylinder, that's even easier, right? Right there. So pi times 5.715 squared times 42, and there's the number for the volume of the cylinder. So how do I get the total volume? Add them up. So we'll take that last answer, which is the cylinder, plus the number for the cone volume, gives us the total volume. But there's one other little part of this now. It tells us that 52% of the space in the rocket is needed for fuel. What is the volume to the nearest hundredth of the portion of the rocket that is available for non-fuel items, for everything else besides the fuel? What's going to be the percentage of the rocket that we can use for non-fuel? 48, right? 100 minus 52. Now, how is it, remind us here, My daughter was just doing this last night. 5th grade class, they're starting to do this stuff. So you got to remember, the pressure's on. You got to remember this. How do you take 48% of a number? Good. You multiply by the decimal equivalent of 48%. And really all you're doing when you do that, if that seems weird, it did to her, so I explain it this way. If you think about it as parts of a whole, 48% is just 48 divided by 100, 48 out of 100. So you're multiplying really by that fraction. You're taking the whole volume times the fraction, 48 out of 100. Does that make sense? Okay? So we take this answer times 0.48, and there it is. That's our answer. Okay, that's the volume available to us other than the fuel. So 2260.28, right? Okay, questions on that? There's a number of steps in that, but it's not that bad. Not that bad. Okay, 2 more to go. We're getting there.
Maybe you have a question.
Yes, question. On the last one?
No.
Okay. Okay, alrighty. Okay, so what about this? Oh, that's too big. Let me make that. Okay, what about this guy? Find the volume of the right prism. Okay, so what's the shape of the base here? No? The base. It's a right triangle. This is hard to see. Look at this little sign, little symbol down here. That's a right angle sign, right? So it actually is a right triangle. Okay? So then if we want to find the volume of this, volume is easy. It's just base times height, right? So the base you just told me is a right triangle. Now we're so used to doing equilateral triangles. The one that we used to do most often is just the area of a regular triangle. How would we calculate the area of this right triangle? Yeah, good. So B would just be 1/2 times the base of the triangle, which would be x, right? So 11 times the height, which is x. So 11. So I get half of 121, which is 60.5. Is that right? Well, we can do that on our calculator. Okay, because now let's grab the triangle and sit it down. So if I take that base, there it is, right? Does that make sense? Okay. Okay, so then there's my base area. Now, fortunately, I'm not doing surface area, so I don't need the perimeter of the base, right? I just need the area, which I have. Height is y, that's 6. So all I have to do then to find the volume is just multiply 60.5 times 6, which is 303. Okay? So 303, whatever the units are, cubic, whatever we measure in 6. Okay? Make sense? All right. Hold on, what's at the bottom here? Oh, yeah, this one. Let's do this one. Let's do one of it. Okay, so what about this one? This one looks pretty hard, but it's not a big deal at all. Find the volume of the solid below. Please note that the interior is hollow. Round your answer to the nearest hundredth. Okay, use pi button if necessary. So this is like what is that making? It's like a vase or like an ice cream cone. Yeah, it's like the shell of an ice cream cone. We're finding the volume of it, right? So how do I find the volume of a complicated shape like this? Say it again. Okay, good. I'll find the volume of the big cone and subtract the volume of the small cone from that. Volumes are easy. We're either adding or subtracting. In this case, we're subtracting because we're removing some area, right? So we know the volume of cone. That's a pretty easy one. Just 1/3 pi r squared, right? Now, what's the radius of the big cone? 7. Good. They give us diameter, don't they? So the radius of the big cone is 7. So we could just use our calculator and do this stuff, right? So we know, let's calculate the big volume first. 1/3 times pi times the radius is 7 squared. And then the height of the big cone is h2. What is that? I can't see it. 16. So there's the number. What the heck? What did I just do? That's what I want. There we go. Okay. So there's the height of, or excuse me, the volume of the big cone. Let's calculate the volume of the small cone. Now here's a trick. Watch this. Let me go up and grab, I'm going to grab that first calculation, and then what do I do to it? Yeah, change the numbers. I'll change the 7 to 5, and I'll change the 16 to 9. Okay, right? So there's the volume of the small cone. I'll just grab that big one minus small one. There it is. Okay? No biggie? Okay, we're about there. Last problem. Oh, this is a quick one. No big deal at all. Okay, hang tight. You've done such a great job. We got one more to go and we're done. One more and we're out of here. The surface area of a sphere is given to us as 16 pi. They want us to find the circumference, right? So what do we do with that surface area that they give to us first? Okay, we've got to, what are we solving for? Circumference, but in order to know circumference, we have to plug in a value of radius. Good. Okay, so the first thing we have to do is we'll take this surface area, 4 pi r squared equals 16 pi. How do I solve for r? Divide by 4 pi. So that gives me r squared equals what? 4. So what's r? 2. Okay, good. So then if we're calculating circumference, I'm just going to plug 2 in for the radius. And here's the part, everyone focus up here for 30 seconds and we're done. Okay, look, here's where, very easy, but what do we not want to do here with that pi? We don't want to put it into the calculator. We want to leave it in terms of pi. So 2 times pi times 2 is 4 pi. That's an exact answer. So in Moodle, we would just enter 4p. Okay? Done. All right.